liberty of rewriting the functions. The way they're shown in the original text does not use parentheses, but looking at the problem, this is more similar to what I've seen previously. So I've rewritten them as if there were parentheses around the x plus 2 here, like that, and the x plus 1 here. So to find f over g, we simply put 5x over x plus 2 over g, which is 6 over x plus 1. We would then simplify this, and we would get 5x over x plus 2. And when you divide by a fraction, you flip and multiply. So multiply x plus 1 over 6, which is going to be 5x squared plus 5 over 6x plus 12. So this is the function. Now for the domain, we have a couple of restrictions. First of all, this can't be 0. So x plus 2 cannot equal 0. That would make the numerator undefined, which would make the whole thing undefined. So that means x cannot equal -2. Over here, x plus 1 cannot equal 0. That would make our denominator undefined. So we get that x cannot be -1. And finally, this cannot equal 0. Now in this case, no acceptable value for x will give us 0, except if the bottom was 0, we'd get undefined. So that's already covered. And then finally, in our very final answer, that cannot be 0. So 6x plus 12 cannot be 0. So then 6x cannot equal -12. And we get what we already knew, x cannot be -2. So our domain will be all real numbers except, so see x is a member of real numbers, but x is not equal to -2 or -1. Or if we want to put this in interval form, x can be from -infinity to -2, not inclusive, union from -2 to -1, oops, not inclusive, and finally from -1 to +infinity. That's the problem.